Good morning.
Good morning, Adnan.
Morning, and how are you?
You can start the class, Adnan.
Okay, thank you. Let me share the screen. Okay, dear students, welcome to the science class, chemistry. Today we will discuss 6 different topics, and we are starting from matter. So you already will have a certain idea that what basically matter is. So we simply define matter as anything that has mass or which occupies space. We call that matter. And our second topic for today will be weighing in. So what do we actually mean by weighing in is that we need to measure or measure the weight or the matter in different scenarios, right? Sometimes when we try to measure matter, we compare it with a fixed mass, and sometimes we weigh it with a spring balance and some other instruments that we will see in a while. And after that, we have types of matter. We have different types of matter, like you will already familiar with solids, liquids, and gases, which are very basic types of matter. But apart from that, liquid, solid, and gases, we have different types. For example, pure substances and impure substances, and mixtures. And then we have homogeneous mixtures and heterogeneous mixtures and all that. So all these, they come in the types of matter. Then we have combinations of matter. We will see that matter is composed of specific atoms, right? It's not that you mix something and it will be converted into something else, right? You have to mix two things with a specific proportion. Only then you will be able to have another thing. So then we have a concentration and density. So we are starting from matter, and matter has anything that has mass and occupies space. For example, we have a football, right? So it is a huge sphere. It has air inside. The outermost layer is solid, and then we have air. Air is a mixture of different gases. So different types of matters they exist. Mainly, matter can be divided into solids, liquids, gases, and plasma state. So matter exists in various forms and states around liquids, gases, and solids. Matter is made up of atoms, which are building blocks of matter. So just like when we try to build our home, we start from bricks, right? We have small bricks and we keep that brick one by one on the top of each other, and eventually we build a house. So similarly, matter is composed of small indivisible particles that are called atoms. By indivisible, I mean that you cannot purify that substance more, right? So it's a pure substance. So this was a short introduction of matter, and then now we are moving forward to the explanation of matter. So we mostly study matter in schools and colleges. Like okay, matter has three different types: liquids, and solids, and gases. And the basic way, or the deeper understanding to have about matter is the kinetic model of matter, right? So it is by learning what actually matter is. So this is very important. So what is a kinetic model of matter? Kinetic model of matter, just like the name indicates, it's about kinetic theory, right? So you may have heard about the kinetic force, or the kinetic energy and potential energy. What is a kinetic energy? Kinetic energy is basically the energy which comes with motion, or when something is moving, right? For example, you have a car, and the car is moving, the car is on the road, so we will say that that car has a kinetic energy, right? And when your car is parked in a garage, we will say that it has a zero kinetic energy because it is at rest. So what is a kinetic energy? Kinetic energy is something which comes due to motion. Anything which is moving, it will have a kinetic energy. So what happens in solids is that strong attractive forces between atoms and molecules exists, very low kinetic energy. So when the atoms are held together very tightly, they cannot move, they cannot vibrate that much, right? So when they will have a minimum movement, so that is why we will say that solids have a very low kinetic energy. I hope this point is clear. Uh, it's simple to understand, right? For example, like as I just explained it to you guys, that anything when something is at rest, right? For example, I'm sitting right now, so I don't have that much kinetic energy. And if I'm moving, if I start running, so my kinetic energy will start increasing, right? So this is the simple way of understanding this concept of kinetic energy. So always remember that solids, they have a very low kinetic energy. Why? It is because the atoms are held very tightly, and they have very strong forces of attraction between them. So now we are coming towards liquids. So why liquids are liquids? For example, somebody asks you that how many types of matter do we have? Or we will say that, okay, solids, liquids, and gases. And if somebody asks you that, okay, now tell me why liquids are liquids, so what will you say? So there is an explanation to why liquids are liquids and why solids are solids. And that depends on the kinetic energy and the forces of attraction between the atoms and the molecules of matter. So now we just discussed solids, and now we are coming towards the liquids. So liquids are strong attractive forces between the atoms or molecules, but weaker than solids, kinetic energy higher than solids. So, okay, so this is how we explain that why liquids are basically liquids. That is because liquid molecules or liquid atoms, they have strong attractive forces, but these forces are lower in energy than solids, but the kinetic energy is higher because if the strong attractive forces between the atoms are decreasing, it means that the molecules, they can vibrate more, right? And since they can vibrate more, the kinetic energy will become higher. So this point is also, I guess, clear. And now we are moving towards gases. So air, right? So we are breathing air when we breathe in, when we exhale. So what are we doing? Basically, we are inhaling a mixture of gases from the air in our lungs, and oxygen is absorbed and we release carbon dioxide, right? So what is happening? We are breathing gases. So why gases are gases? That is because in gases we have almost zero forces of attraction. So this is a very important point. You guys should keep taking notes so that you guys can revise after the class, and the main points or the important points you will remember. So gases have weak or no attractive forces between the atoms or molecules, and high kinetic energy. When there is no forces of attraction between atoms and molecules, it means that the molecules and atoms are free to move, right? For example, if you have a balloon and inside the balloon you have a mixture of gases, so all those molecules, they are free to move here and there, and that is called a Brownian motion, right? When a gas molecule or gas atom will be free to go anywhere the molecule wants, right? Within the walls of that container, obviously. So this is why the movement is too strong in gases, and that is why we have a very high kinetic energy in gases. So this was the kinetic model of matter. Now you can see in this picture on the left hand side we have solids, and the atoms or the molecules, they are closely packed and there's no space between them, very little, and they are locked, they cannot move. And this is why we say that there are very strong attractive forces between the atoms, between the molecules in liquid, in solids, and the kinetic energy is very low. Why the kinetic energy is very low in solids? That is because solids have low kinetic energy. And this is a very important point. In mostly you will be asked in your exam that why kinetic energy is very low in solids. So if you look at liquids, these are the liquid molecules, and you can see that they can vibrate a little bit, like more from solids if you compare it with solids. And here in the liquid molecules, we have more space. That means that the forces of attraction between the liquid molecules is low. And since the liquid molecules are vibrating, and that's why they have a higher kinetic energy as compared to solids. And now gases, look at the gases, they are completely free to move here and there, and they will strike to the wall with the walls of the container and they will come back. So there is no forces of attraction between these molecules or these atoms, and we have a very high kinetic energy because the movement is too much. So the more you move, the more the molecules will move. You will have a very high kinetic energy. So again, we have liquids, gases, and solids with matter. So you can see here we have solids. Ice is a solid, and you can see that the molecules, the water molecules, are closely packed. They are rigid, they have a fixed shape, they have a fixed volume, and they cannot be squashed. What do you mean by squash? Squashing is when you try to press something, right? A piece of foam, when you press it, so as you the solids cannot be pressed. So it's simple as that. So when you come to liquids, you can see that they are not rigid, they are flexible, no fixed shape. If you pour water into the bottle, liquid will take shape of the bottle. And if you transfer that liquid into some other container, so the liquid will be transferred, will transformed, it will change its shape and it will take the shape of that container, right? And fixed volume, they have a fixed volume, and they also cannot be squashed. And then we have gases. You can see that they are not rigid, they have no fixed shape, no fixed volume, and can be squashed. So now we are moving towards the second topic, weighing in. So what do we actually mean by weighing in? And by weighing in, we mean that, for example, we have matter, and now we are measuring it, right? We are trying to quantify matter, that how much actually matter, how much matter do we have? So, for example, we have 1 kilo, we will say that we have a kilo. If we say that we have a pound, so we will have a pound, right? So what is weighing in? So weight is a measure of the force exerted on an object due to gravity. So this is a very important point, and you need to understand this. That, for example, if it's the why things have weight, right? It is because of gravity. The stronger the gravity, and the more weight it will have. For example, on Earth we have a certain type of gravity, but if we go to the moon, right? So the moon's gravity is not that strong. If you compare it with Earth, moon has a very low gravity. That's why people can easily jump, and they can jump higher. So your weight will be lesser on the moon as compared to the Earth, and that is because that the gravity of the moon is low as compared to Earth. But the sun's gravity is very strong, and we will weigh more on the surface of the sun, right? So we may not be able to walk, and we may not be able to lift ourselves from the ground. So this is how strong gravity is in the sun. And the strongest gravity that we have in the universe is of black holes. Even light cannot escape a black hole. So if something goes into the black hole, it is converted into a singularity, right? It is converted into a single dot. Even if you throw in a mountain into the black hole, it will be squashed and it will be concentrated in a little tiny dot. So this is how strong gravity exists in the black hole. So here on Earth, we have different types of scales and instruments that we use to measure weight, and they come in various types and sizes. We will see them in a while. So in the unit, so every quantity is represented by a unit. So the unit of measurement for weight is newtons, and it is denoted by a capital N, or pounds. We write it lbs. So this is how the weight is weighed, right? So accurate weighing is crucial in many applications such as cooking, chemistry, and manufacturing. So what is the importance of weighing something, right? For example, why do we need a balance, or why do we need a digital balance, right? Or why do we need a spring balance? That is because we need to know the quantity that we are working with. For example, if you want to cook 1 kilograms of chicken, some of you may have cooked, or you will know how to cook. So it is very important to know that for 1 kilogram of chicken, how much water do you need, right? So that is why you will take 1 kilogram of chicken, so that you can add the related amount of water. Or for example, spices. For example, if you are cooking 1 kilogram of chicken, the weight of spices will be different. And when you will cook 2 kilograms of chicken, so you will have to double it. So according to the quantity, or we can say that many things, they depend on the quantity of the matter that we are dealing with. For example, sometimes you get sick. So it is very important to understand that how much medicine do you need. So this is why each tablet or each capsule is properly measured, so that you do not have to take the overdose, right? For example, you are sick, and you take overdose of medicine, so it will have a very serious reaction on your body, and it can cause some serious circumstances, right? So this is why weighing is very, very important. So I hope I have elaborated the importance of weighing, and why do we measure things, or why do we quantify mass and all that. So you can see here we have different types of balances. We have electronic balance here. This is a very sensitive balance, and it can weigh a mass into very small quantities. We have a type of spring balance. This is also a type of spring balance. This is a simple balance which people used to work with, but it is not used nowadays. It's a very famous symbol for justice, right? That justice should be done, and justice is very important for peace in the world. And this is another type of spring balance here. So these are all the types of spring balances, and they are used to weigh matter. So common weighing instruments include spring scales and different types of balance scales or electronic scales. So digital scales are more accurate, as I just explained it to you guys, that whenever we put something on the digital scale, what will happen? It will give us a reading, right? And we can take that reading and we can do our work. So precision refers to the degree of consistency in repeated measurements, while accuracy refers to the closeness of the measurement to the true value. So sometimes it happens that when we are trying to weigh something, sometimes we will have errors, right? We may not be able to put up the mass that we were trying to put in, or there might be something wrong with the balance. So this is why sometimes the values are not accurate, and that's why we have to repeat the measurement. So that is why we do not rely on a single measurement. When we are weighing something, we repeat it, and then we take the average so that we can avoid different types of errors in our measurement. So I hope this point is clear. Now we have types of matter. Here we will discuss types of matter in detail. And we have different types of matter. Classification of matter, as I just said, matter can be classified as pure substances or mixtures. So what are pure substances? Pure substances are made up of only one type of atom or molecule, while mixtures are made up of two or more substances physically combined. So what happens is that when you physically combine something, so pure substances are created. Pure substances, we have two main types. We have elements. We can call elements pure, and we can call compounds pure. So these are two major types of pure substances: elements and compounds. So pure substances are made up of only one type of atom or molecule, while mixtures are made up of two or more substances physically combined, and mixtures are not included in pure substances. Please remember this. This point is important, that we have two types of pure substances. The first one is elements, and the second one is compounds. And mixtures, they are not included. They are not considered as pure substances. So pure substances can be further classified as elements or compounds. We have different types of elements. We have 118 different types of elements in the periodic table. Some of them are in the solid state. Most of them are in the solid states, and some of them are in the liquid states. And then we have some of them they are in gaseous states. For example, hydrogen. Hydrogen is the example of an element. It is a pure substance, and it exists as a gas. For example, iron or aluminum, gold. So these are pure substances, these are elements, and they exist as solids. And we have chlorine, or we have mercury, right? Or we have bromine, so or iodine. So mercury and iodine, they exist in liquid form at a room temperature, and these are all the examples of pure elements. So I hope this point is clear. So pure compounds can be further classified as elements or compounds. So what are compounds? When two elements, they combine together in a fixed ratio, they form a new thing, right? Which will have a different properties than the individual atoms. So this is how this is why this is important to understand that what is the difference between atoms and the compounds. So water is the example of a compound, and water is composed of hydrogen and oxygen. Hydrogen is a gas, oxygen is a gas, but when they combine, they form liquid. So liquid have different properties. Here is a classification of matter and the types of matter. You can see matter, the way we defined it, occupies space and possesses mass, may exist as solid, liquid, or gas, and it can be further classified into pure substance, a pure substance, and mixtures. A pure substance, a matter having invariant chemical composition and distinct properties. The chemical composition is fixed, it is pure, right? You can predict it, and it has distinct properties. So this is why we say that these compounds, these elements, or these compounds, they are pure. Then we have mixture, a matter consisting of two or more pure substances that retain their individual identities and can be separated by physical methods. And if we go into further detail, we have homogeneous and we have heterogeneous. In homogeneous mixtures, or mixture having a uniform composition and properties throughout, also called a solution. A homogeneous mixture is also called a homogeneous mixture is also called a solution. Or heterogeneous mixture, not uniform in composition and properties throughout. So what will be the example of a homogeneous mixture? That will be your cup of coffee, right? That the sugar is evenly distributed if you have added sugar, and you cannot differentiate between the components of that mixture. So this is why we say that we have a homogeneity in that mixture. And now, if we talk about element, so pure substance can be divided into element and compound. So fundamental substance cannot be separated into simple substances by chemical methods. Compound, substance composed of two or more elements in fixed proportions, can be separated into simpler substances and elements only by chemical methods. To split a compound, you will need a chemical method, right? You cannot just simply use your hands to separate a compound. For example, if you have water, and you cannot simply grab oxygen and hydrogen and remove the two from that compound. That's not possible. You will have to apply experiments. You will need a laboratory in order to separate oxygen and hydrogen from that compound, right? So chemical methods of separation include electrolysis. How do we do that? We use electrolysis to separate compounds into individual atoms. And physical methods of separation include filtration, distillation, and crystallization. Elements are pure substances that cannot be broken down into simpler substances by chemical means, and compounds are pure substances made up of two or more elements chemically combined. Examples of pure substances include gold. The symbol of gold is Au, and water, H2O, and sodium chloride, NaCl. So as you can see here, that water has three different atoms in total, and two different types of atoms. So how many atoms of oxygen do we have in the water molecule? One. And how many hydrogen atoms do we have in water? We have two. And total number of total number of atoms that we have in water, they are three. Two hydrogens and one oxygen. Now we have a sodium chloride. It is an ionic compound. It is composed of sodium and chloride. You can see that these two, both of them, they are elements. They are pure substances. And the atomic number for sodium is 23. Atomic weight, atomic number is 11. And for chlorine, the atomic mass is 35.5. So this is how we represent different types of compounds with the formulas by which that shows us the composition of the atoms that we have in the molecule. So mixtures are made up of two or more physically combined atoms or stuff. So homogeneous mixtures have a uniform composition throughout, while heterogeneous mixtures have a uniform composition, have a non-uniform composition. Examples of mixtures in daily life include air, salt water, and milk. When you drink milk, you think that you are drinking just one thing, but milk is not one thing, right? For if you look closely under the microscope, or if you analyze it in a lab, you will find out that milk is a mixture of different substances. For example, we have different types of molecules in milk. We have carbohydrates, we have lipids, we have different, right? So we have proteins. So milk is a mixture of carbohydrates, lipids, fats, and proteins. Okay, so I hope you will remember this, that milk is a mixture. Salt water. By salt water, we mean seawater, right? You cannot drink it. That's very like the taste is very bitter and it's too salty. Never try to drink salt water or seawater. It is nowadays highly polluted, and you may get sick, or you may get like a nauseous feeling or a vomiting and all that. Air, we breathe clean air in most of the cities. So air is a mixture of different gases. And what is the composition of air? We have oxygen, we have nitrogen. Nitrogen has the highest percentage in air. It is more than 70%. Oxygen, it is 23%. And then we have trace amounts of rare gases. We have helium, and we have argon, and we have carbon dioxide, and we have methane, we have greenhouse gases, and all that, right? So these are all the examples of mixtures. So to further elaborate, to further explain the homogeneous mixture, here we have a cup of coffee. So why do we say that a cup of coffee is a homogeneous mixture? Because you can see that you cannot differentiate between coffee beans. You cannot differentiate between water. It's all black colored liquid, right? And you cannot see different things inside your cup of coffee. If it's a pure coffee, if it's a black coffee, of course. So the sugar is dissolved in it. So you cannot identify that where sugar molecules are at the moment. And heterogeneous mixture, this is an example of a heterogeneous mixture. It is a bowl of your cereal that you take in your breakfast in the morning. When you pour milk and then you add your cereal, it may contain cornflakes, it may contain fruits like strawberries or other blueberries and all that. And the cereal or the strawberries, they are swimming, or they are submerged in your cereal in the liquid. So this is a mixture, and it is a heterogeneous mixture. And why do we call that a heterogeneous mixture? It is because you can literally pick that where the different types of ingredients are. For example, look at this bowl. You can simply pick up this strawberry. You can simply pick this cornflake, and they are not evenly distributed. They are just on the surface. Here, on a deeper level, you may have a lesser quantity as compared to the one that we have on top. So I hope this concept of homogeneous mixture and heterogeneous mixture is clear, and we are safe to move forward. Now, we will deal with characteristics of matter. Here we will discuss different properties of matter. We will discuss physical properties of matter. We will talk about that what basically physical properties are. and then we will talk about chemical properties. We will define what chemical properties are, and what different types of chemical properties do we have. So let's begin this topic. So characteristics of matter. Physical properties are characteristics of matter and that can be observed without changing the identity of the substance. So for example, if I ask you that what are my physical properties? So you can say that I wear glasses, I have a beard, I have hair on my head, right? I have a brown skin color. So these are my physical properties. You can see and you can observe, right? So these are physical properties that you can see and that you can measure in real time just by observing them. Physical properties include color, as I just said, shape, texture, density, order, etc. So if you are smelling something, if you have a compound and you smell it, right? You bring it to your nose and you smell that compound. That would be a physical property. Physical properties can be observed and measured using various tools and techniques. So sometimes we have to apply different tools and different techniques to measure physical properties, and how we do that we will see shortly. So as I just said, that color, shape, texture, or order are examples of sensory physical properties. So what are sensory physical properties? That we have 5 or 6 basic senses, and we have 5 senses. So with those 5 senses, we can sense these properties. Color, how do we observe color? By looking at it, but we use our eyes, we use our eyesight, right? How do we measure shape, right? So by using our hands, we touch it. Texture, we touch it. Odor, we use our sense of smell. So these are all sensory physical properties. So density, what is a density? Density is a measure of the amount of matter in a given volume, while boiling point is the temperature at which a substance changes from a liquid to gas, right? So density is defined as mass per unit volume. If you have a more mass confined in a small volume, the density will be high. And if you have a more mass, but the volume is also high, the density will be low. So this is how density is measured. It's the formula of density is m mass divided by volume. Conductivity, what is conductivity? Conductivity refers to a material's ability to conduct electricity, while magnetism refers to a material's ability to be attracted to a magnet. Here we have another slide. So chemical properties. So chemical properties are characteristics of matter that can only be observed by changing the identity of the substance. So just like we saw that physical properties we can observe, but we cannot observe chemical properties just like that. Chemical properties are characteristics of matter that can only be observed by changing the identity of the substance. Like the identity will be changed. Whatever you are trying to analyze, it will change its nature. Okay, so examples of chemical properties include reactivity or heat. For example, you want to know how much heat is a certain reaction is producing. So you have to break the compound, right? So the compound will be broken into 2 different or 3 different molecules, depending on the nature of the compound. So chemical properties involve the ability of a substance to undergo chemical reactions or transformations. Chemical reactions involve the rearrangement of atoms to form new substances with different properties. What do we mean by that? For example, we have two atoms in a compound. So the one compound is reacting with another compound. So all the atoms, they will be shuffled, right? So for example, if carbon dioxide or oxygen is reacting with carbon, a charcoal. You are burning charcoal in the presence of air. So what will happen? The charcoal will be converted into ashes. It will be converted into carbon dioxide, and it will be converted into water. So water, carbon will react with air, and it will produce moisture, water, and it will produce carbon dioxide. So what happened in that reaction? The atoms, they shuffled. They were in a previous arrangement. They were combined in a different ratio before, and now the ratio is different and the connectivity pattern is different. So identifying chemical properties often requires performing experiments or observations that result in a chemical change. So if you look here, physical properties, as I told you, color, like if you have apple, right? So if you have a red colored apple, so the physical property of that apple is, you will say that that apple has a red color, right? For example, if you go to the supermarket and you want to buy a banana, and a banana will have a yellow color, right? So that's the physical property of the banana. And now you want to measure that what's the length of the banana, or if you are trying to measure the circumference or the diameter of the apple, so you will use a string, or you will cut it, right? Or you will use a ruler. A volume is a physical property. Opacity is also a physical property. It is the value of the object by which it blocks the light, right? For example, I am opaque. Light cannot pass through me, but water, it is not opaque. Light can pass through it. Now, chemical properties, we have acidity, we have reactivity, we have flammability, we have toxicity. So all these are different types of chemical properties. We are studying this under the characteristics of matter. So further, now we are looking more at chemical changes. So rusting. So what is rusting? What happens when something is rusty, right? A key or a lock or a door handle. If you leave it open in the moisture, and when you put some water on it, what will happen? It will start rust. Then we have burning of wood. It's a chemical property. Metabolism. We eat something and it is digested, and we get energy from it. Cooking an egg, frying an egg, boiling an egg, it's a chemical change. Baking a cake, making a pizza, or baking a pizza dough, it's a chemical reaction. Electroplating, rotting banana, you can see here that the black spots on it. So what is happening here? We are seeing a chemical change in it. Vinegar and baking, soda mixture, fireworks, and chemical battery. So now we are moving towards combinations of matter, and what is basically a combination of matter. In combinations of matter, chemical reactions involve the combustion, rearrangement, or separation of atoms to form new substances. The reactants are the starting substances in a chemical reaction, while products are the substances formed as a result of the reaction. So these 2 points, they are self-explanatory. I think we cannot, they don't need as such explanation. Balancing chemical equations is essential to ensure that the number of atoms on both sides of the equation is equal. So now I will teach you how to balance a chemical equation, and balancing a chemical equation is very important, and it will give you a better idea that how different combinations of matter take place in a balanced chemical equation. So as you can see here, we have a molecule. On the left hand side, we have reactants, and on the right hand side we have products, right? So we have two reactants. We have propane, C3H8. We have oxygen, and they are these two. And what are these? These are compounds, and these are pure substances. Propane is a gas, it's a pure substance, and oxygen is a gas. It is also a pure substance. You can see here that oxygen molecule, it contains two atoms, and you can see here that propane, it contains 3 atoms of carbon and 8 atoms of hydrogen, and they all have single bonds. And here on the right hand side in the reactants, we have water and we have carbon dioxide, but the equation is not balanced. The mass on the left hand side, the mass of the matter on the left hand side is not equal to the mass of matter on the right hand side. So what will you do? The best way is that you should write down individually the number of atoms of the right hand side and the number of atoms on the right hand side. For example, we have 3 carbon atoms. So we have written here C carbon equals 3. And how many hydrogen atoms do we have? We have 8. So that is why we have written hydrogen equals 8. How many oxygen atoms do we have? We have 2. So that is why we have written 2 here. On the right hand side, how many carbon atoms do we have? We have a single carbon. That's why we have written 1. How many hydrogens do we have? We have 2. How do we know that we have 2? It's from here. It's written here. You can see, right? And how many oxygen atoms do we have on the right hand side? 3. 2 are here and 1 this one. So 2 plus 1, 3. So the first step is to write individually the number of atoms on the left hand side and the number of atoms on the right hand side, one by one. So the second step is that you need to check the difference, right? You can see here we have 3 carbon atoms here, we have 1 carbon atom here, we have a difference. We have 8 hydrogens here, we have 2 here, we have 2 oxygen atoms on the left hand side, and we have 3 hydrogen atoms on the right hand side. So let's try to balance it. So here we have 3 carbon atoms, here we have only 1. So what should we do? So we can make this 3, right? So we will write 3 here, just like that. And when we will write 3 here, now the number of oxygen atoms, they have been changed. You can see here 3 times 2. What is 3 times 2? 6, and plus 1, 7. So when we added 3 here, now we have 3 carbons, but what happened? The number of oxygen atoms, they changed, and they went from 3 to 7. But that's okay, don't worry about it. It's a trial and error method. You will enjoy it, and balancing chemical equations is a fun. Now, in order to make 8 hydrogens on the right hand side, what will you do? You will put 4 here. So 4 times 2, 8, right? So now the number of hydrogens are balanced, 8 on the left hand side and 4 times 2, 8 on the right hand side. But what happens by changing the number of hydrogens, the oxygen has been changed again, right? So 7, and then we have to add more, 3 more, and this will become 10, right? So now in the end, so if we have 10 oxygen atoms on the right hand side, how do we have 10 atoms? 3 times 2, 6 oxygens, and 6 plus 4 oxygens here. So 6 plus 4, 10. So now we will put 5 here with oxygen. So 5 times 2, 10. So now you can see here that on the left hand side, the number of oxygens is balanced, and the number of oxygen atoms on the right hand side, it was also balanced. So carbon is balanced 3 here. How many carbon atoms do we have? 3. How many hydrogen atoms do we have? 8. How many atoms of hydrogen do we have on the right hand side? We have 8. And oxygen 10 and 10. So now our equation is balanced. So this is how we balance our chemical equations. So this was the combination of matter. So this was the final slide of today's lecture. We started from matter. We discussed matter. Now we have 4 minutes left where we will try to summarize it. We discussed different types of matters. We talked about solids, liquids, and gases. Let me take you to the slide so that we can revise. I think this is the best slide to revise. So solids, strong attractive forces between atoms and molecules, but very low kinetic energy. Liquids, they have strong attractive forces between atoms and molecules, but they are weaker than solids. They have kinetic energy higher than solids. Why? It is because the molecules have a higher movement. And in gases, kinetic energy is very high, potential energy is very low, because the movement of molecules in gases, it is too much, right? And the attractive forces in gases, they are weak, as I explained using this picture. So after that, we talked about weight, and we said that we have different instruments that we weight. We have a digital balance, we have spring balances, right? So here is a picture of a digital balance. So these are all different types of balances that we use. And why do we need to weigh something? It is because for different reactions, we need to know how much quantity we are adding in. So after that, we move to the types of matter, and this will be a good explanation for the types of matter. So please remember that we are now summarizing, we are just revising. We have already concluded the presentation. So matter can be divided into pure substance and mixture, and pure substance can be further classified into element and compound. Mixture can be further classified into homogeneous and heterogeneous mixtures. So here is an example of a homogeneous mixture, a cup of coffee. And then we have a heterogeneous mixture here, your cereal bowl. So this was all today from my side. If you have any questions, so please ask, otherwise we will conclude. Thank you very much.
Thank you so much for enlightening us. Have a wonderful day for you. Okay? Thank you,
Thank
just my God. The class is now. Thank you.